cases. We will then also run these test cases manually, semi-automatically and fully automated. So what that does, it gives you an impression, which is one of the major benefits of test automation with a model-based approach, that you have an absolutely seamless world between manual execution, semi-automated execution, and fully automated. And it's like a slider. You can go back and forth and you can expand at any time on your automation in an incremental fashion, although all you do is you apply plain English. Okay? So what that illustrates is that whilst most technologies today, most concepts, typically separate the teams, the testing teams, into two silos. There's the manual testers, and these guys are subject matter experts and go after the system, are business analysts or test analysts with no programming skills, and they do manual testing. They write the test cases in prose, Word or Excel or some technology, and then do testing. And then there's the automation team, usually a small team of 2, 3, 4, 5 highly skilled experts who program and maintain test automation frameworks at best. Okay, but it's usually siloed, and you see a breakdown often between these teams in their efficiency, how they collaborate. Now I will show that and illustrate that as well. That's not necessarily longer the case. You can collaborate in a team much more efficiently using this approach. And then we will expand on the basic scenario. So I will only use a UI, so graphical user interface technology, the first one, because it's not about the breadth of coverage, it's just understanding basic concepts. But we will then expand a UI automation with non-UI automation. So we will do, for example, a web service. We scan a web service live off the internet, and we integrate this non-UI automation or service automation straight into our basic scenario, where you see it runs end to end. And we will expand on variances. So we will build in them many variances into the basic scenario, where we only capture the basic flow in first place. And last but not least, the very important point is here the impact of change. And this really for those of you who have test automation experience, right? For you, I think that concept will come in very clearly, and you can follow that straight. For those of you who don't have much experience, I'm not too sure if you will really relate to this. I like to use the analogy of a dentist. If you have never had toothache, you don't value his service, okay? If you have had pain, you love him for what he can do. And that's pretty much here the last part, the impact of change, which again separates the concept of model-based testing significantly from other technologies or other concepts. Okay? So we go to impact of change, we change test logic, we add something into an existing interface, we'll change variances, but we will also change code. On-the-fly code change, and I'll show you the impact, how you deal with change of code, and how it affects you. Okay, that's the main agenda for tonight, and that was the purpose. With that, I go back to the slide deck, because what I need to show you now is at least a bit of a concept for those who have not had a chance to come to the last SimWorld testing forum and understand what this is all about. Now, for those of you who are interested as well, we have also implemented a concept of computer-aided test design. This is not part of tonight. It could be a separate session, conceptually, as well as tool-guided if you want it. Computer-aided test design is a systematic approach to deriving your test cases in the first place, regardless of the type of execution. If you execute manually or automatically, is a completely separate concern. What that does, it's a bit of a different approach to testing. Rather than defining your test cases case by case by case by case, you define a process flow and you define a data model. And then you classify in your data model, you classify your data with happy day scenarios, alternatives, valids, invalids, and the likes, and then you can apply computer-aided combinatorial analysis, and it will generate all the test cases for you based on a model. So it's again a model-based technique, but for a different purpose. It's not for the automation, it's for generating the testing need. That gives you the benefits of automated gap analysis and redundancy analysis. You can, without ever looking into your test suite, into your scenarios, I only need to look at the model and I can do some very simple checks. And I can find out if your test suite satisfies the model or not, or if you have over-engineered your testing, your test suite, your portfolio. Okay, so we won't have the time to go through the story and history, why and how model-based testing came about. I'm happy to tell you that story after the demonstration for those of you who are interested. What was the challenge and why do we need it and why other technologies when it fit for purpose. But in a nutshell, the origin was with Allianz and a technology migration that had specific issues that could not be addressed with record and replay technologies and could not be addressed with test automation, were very, very difficult to address with test automation frameworks. And that was by and large that the business logic in the technology migration was the same. The claims processing and everything was the same, but they changed the underlying technology from Power Builder to Java. How do you make maximum reuse of your existing subject matter expertise and your test logic and run automation against both systems? One, to establish the existing system as the source of truth. Two, to use the same test logic to run it against the new system. That was the driver, the original driver, that led us to look at what's out there and find nothing really suited our problem. And that's why we had to look outside the frame and go with a different approach. Now, by and large, you can categorize existing technologies today in 3 generations. Generation 1, commercial solutions were available as early as in the 80s, okay, early 80s, is record and replay. I know a few of you have experienced. For those who don't, it is literally exactly what it says, record and replay. If you record this video today, you could play it back and you would get exactly the same result as listening to me now. In that sense, all it is, it's a program that sits on your computer and it records your keystrokes and your mouse clicks, okay? It turns that into a little program which you can then run later and it will do exactly the same. It simulates these keystrokes and mouse clicks. Now, therefore, it has no knowledge about your system under test and there's no test logic either. It's a very dumb technique to repeat and simulate a user, okay? That has value, don't get me wrong. There's value for that. If I was an IT administrator and I have to check there's a certain services up and running every day on an infrastructure that doesn't change over years, because we're using Windows XP for 15 years now, you know what? Use it, because it's quick and it serves the purpose. In systems maintenance and in software development, where the only real constant is change, it has little use, because each and every change will break your script. It's too fragile, okay? The second generation then appeared in the early 90s, commercially, were test automation frameworks. And the test automation frameworks, their attempt is to separate the test logic from the automation, okay? Whilst in a record and replay, you embed implicit logic by recording the user behavior into the code, we now try to rip out that behavior into test logic so we can use the test logic again. Respectively, we try to build a layer of functions, right? It's functional calls that we can then use to assemble test cases, okay? It does address the fragility. It works, there's no doubt. Okay, it was the best that we had in the 90s and probably largely out for the first half of the 2000s. However, it's a rather costly approach, because what you do is you need to develop these test automation frameworks and you need to maintain them. Okay, and that means you are running a parallel software development project on top of your actual systems development and maintenance. Right? And that was, by and large, too much of an investment for what we wanted to do. And so the question is, what could we do differently? Right? Now, the idea was that we look at outside the frame of test automation, because that was all script-based. We needed a different approach for reuse, and we didn't have to look far in that sense, because object orientation came on the market in the late 70s. Smalltalk was one of the first implementations. Now again, for those who don't have programming experience, there was from 1940s to up about 1970s, it was all procedural programming. You program functions by function. Test automation frameworks are pretty much that. You program function by function. And then you can arrange these functions into a scenario, then you can execute them in a row, and it will do a login, and it will do some navigation, it will do some field entry, whatever. But there is some embedded code in your function. So if you wanted to change the sequence of the login, that it doesn't act on the user field first, but it should act on the password first, you know, you can rewrite your function, or you need to build in some function where you have a toggling switch for the function where you said reverse the actions, how you act. Okay, there is embedded code, embedded logic. So it's never clearly separated in a concern between test automation, the pure running of the systems, and the test logic, because some logic is embedded. Now, in order to avoid that, the idea was, okay, this is your systems landscape. You have all your systems here. You might have an application server, a web server, where you have some web services that you offer for applications to consume or integrate with your applications. You might have browser-based interfaces where you push your applications out into the internet. You might need to talk to a database directly because you do some verifications at the backend database. You might have some desktop applications or enterprise applications. You might have SAP or Siebel to test, or you might have Java and .NET applications to test with desktop interfaces. There might be Power Builder or XML. You might have non-UI. You might have a Swift protocol in the banking industry. You might have fixed in the security trading industry. You might have a pure, a proprietary API layer that you need to test. And you might also have a host system. You might have a mainframe where you have a green screen and that's all you have to interact. Now the idea was that our test cases should be in plain English at all times, regardless of the testing stage. If you do a component, if you run a component test and you test a web service in isolation, only its function, not its use within a scenario, well, by all means, it should be plain English in the test logic because it still has a contract. It still has capabilities that it offers, right? If you test a system test, you probably have a bit more than just a component. You test a scenario that the system is offers. What if you go to system integration testing? Now you suddenly might integrate different technologies and different techniques in one single scenario, UI and non-UI. And so the same is for user acceptance testing. So the idea was that the whole testing logic should always be in plain English, or plain Mandarin, or plain Hindi, or whatever, in a plain human readable language, but not in technology. And therefore we need to achieve this separation of layer. But rather than coding that and maintaining that as you do in test automation framework, where you still have some hardwired logic from your test cases in your function calls, we needed a different approach. And the idea was to use exactly the same what object orientation does. Separation of concern, encapsulation, reuse, and polymorphism. Okay? So the idea was, rather than having a mindset of automating test cases case by case, we automate systems. How do you automate systems if you have no test logic? You scan the interfaces. You build an automation model by scanning the system's interfaces, because if the context here and today is black box functional testing, we don't need the code. Every behavior that we get from all our systems, from our landscape, is exposed through the system interfaces. Be it user interfaces that we use as human beings, or be it non-UI interfaces, application programming interfaces, web services and the like, that other systems use to communicate with us. Right? So the idea was, we don't build functions and against the system based with a mindset of test cases. We built an automation model that is an abstraction of our IT landscape and its interfaces. And there's nothing in it. There's no sequence in it. There's no function call in it. There's no test data in it. There's no test description in it. There's no test step in it. It's, as a matter of fact, it's pretty dumb. All it knows, it knows how to interact with the interface. It is a precise proxy of the interface. Okay? And what we can then do, we can marry this up with the actual test logic. Okay? We can then we can drag and drop. These are like Lego blocks, which we can use to assemble test cases. We can then marry that up, these interfaces, if that plain English test case has a couple of actions that happen to be executed on a particular HTML page. Well, you know what? Then we marry it up. We say, okay, well, you know what? These couple of actions will act there, but there is no static binding. It all happens only at runtime. Okay. When you execute, then Tosca will read the instructions here and will instantiate the classes. So for those of you who has object-oriented programming experience, okay, a few. If you were to think in object orientation, who can tell me what is the class and what is the object? What is the class? What is your definition that you program? And what is the runtime object when you execute your system?
Instance.
What is the instance of the class? It's very clear on there. What do you think is your structural definition?
One.
That's right. In that analogy, these are your classes in object orientation. They're static. There's no runtime instance here. The runtime instance comes in from the test logic. That's what you tell it to do at the runtime. Okay? It's the same principle as it's just object orientation through and through. Okay, I guess with that I can launch into the demonstration. Now, what you will see later on as well, if you had then a change to a web page, let's say they remove a field that you used to use, they replaced it with something else. They might have had a list box, now it's a combo box. They might have had a list, now it's a table. They might have moved the object altogether from screen 1 to screen 3 because they changed the sequence of the flow. Okay? We can adopt these changes without any program. Okay? You can go and change that without any program. You're not hardwired in that sense. So if that change happens, and I will show that as well, what we need to do is we synchronize the module with the interface. We don't need to touch the test cases unless the change is a business-driven change rather than a technology-driven change. Okay, it depends on the type of change. If it's a business-driven change, let's say someone from the business adds a mandatory piece of information in your business process that you didn't have, and that blocks your execution from progressing because the application screams at you and says, unless you give me that piece of information, I won't allow you to proceed. Then you fix it in a module and you propagate the change into your test cases. One single point of maintenance, not distributed in thousands of artifacts. Okay? Reduce the amount of maintenance by using the same principles. And what you then can do is you can build very robust models, but anyone can use it. You don't need to be a rocket scientist or a programmer to use it and build automated test cases. Okay? All right. Oh. So, scary. Let's go into the presentation. Now, for whatever reason you can't see anything. Coming back now. Okay, now this is Tosca. Tosca is an implementation of model-based test automation. Okay, it's been in the market since 2005. And what I will do is that I will build a basic scenario. I won't explain all the concepts of it. It's an open platform that covers the entire testing life cycle. In that sense, it covers it from test management to test specification to test reporting, test execution, manual, automated, including computer-aided test design. The two differences to our competitors is we offer model-based test automation as opposed to script-based, and we offer computer-aided test design, which nobody else has. Okay, so these are the two differences. But let me go into building a basic scenario with you now. Let's assume that we have here as an application to start with, we have an insurance calculator. We have an insurance calculator where we can insure different types of vehicles. For example, a car, motorbike, whatever. And then we need to provide vehicle data, obviously. We need to provide data about the insurance. We need to choose what coverage we want to have, and then we get a quote. Okay? So what we will do is, in the first instance, we will build a basic flow, kind of a happy day scenario, through this insurance calculator until we get to the quote. Okay? And I will illustrate you a few concepts that I talked about earlier. In the first two steps, I will use an existing model. I show you, if you were a test analyst, you come into a project, there's an existing implementation already. You would not start straight away building your own automation model, because you might just build redundancies because there is something existing already. So firstly, we look for reuse. And in the first two steps, I will show you how we use the module to create test steps that are automated straight away. We won't start manual, we start straight with automation. In the third step, I will show you how we build the modules if nothing is there, and then use it. And in the fourth step, we will assume that the system is not even there. We will start manually and then automate later. So you see the top-down as well as the bottom-up approach. If you are in brownfield applications, meaning existing ones that you want to automate, you probably have more bottom-up, because you can speed up your entire test creation. If it's a greenfield where all you have is where all you have is requirement specification and you have no system to scan and build up the automation model, you can start straight away by building your manual test logic, your pros, and then automate later. So we'll look at both. All right, so here we want to build another scenario for a car insurance. And then all I do is I drag and drop that requirement with these test cases over to my blue section. So you will see there's various sections. The yellow section represents the requirements and the traceability into our test artifacts. The red section, and you get dashboards and all of that. The red section is where you can do computer-aided test design, build a test data model that then drives your process behavior, your process templates. The blue section is where you have your test cases, and we specify these test cases. The amber section is where we build and maintain the automation model. And then the green section is where we execute. This is where we then say when and on which environment do we execute it and who is responsible and how we aggregate the results. This is where we get our test logs. Okay. All right, so here we have our test case. I will give you the name. So let's say we are testing a BMW, or actually let me do a Mini Cooper. And the first step that we have to do, remember, I will start straight in a brownfield approach where I start with automation straight away. Here's the application. The interface is where we choose the type of vehicle. So if I join a team that has been working on this before, I would look here in my amber section, is there anywhere a module that represents that interface, the type of vehicle? And I have it, so what I do is I simply drag and drop that module onto my test case. And it will create here my first test step. I can rename this into an action, obviously, and say select type of vehicle. And then all I do is I say, okay, I'm selecting here a car, and then I click next. And what it offers also is here a scratchbook. The scratchbook is the debugger for the tester. So rather than talking about, theoretical process, we can straight execute the automation and see how well we fare against really running the system in an automated fashion. Let me do this again, so you see this. We are on the vehicle data interface page, so we enter vehicle data. If I'm a test analyst, I would go to the intersection and say, is there a vehicle data component that represents that interface? If yes, all I need to do is I drag and drop this onto my test case. And I get the next, as you can see here, the next test step, and I can rename this against in an action which is enter the vehicle data. And right now it doesn't do anything. There's no action yet and no data defined against it. Since I'm building only a happy day scenario, I will provide values right now and actions. We will later on replace these values in the specification through variances driven from test design. Okay? So in this case I'm saying this is a Mini. This case the make is a Mini Cooper. And the performance is 100 kilowatts. Now I'm only using the mandatory fields here. The list price, extremely expensive here in Singapore, as I've learned. Mileage maybe 10,000 kilometers per year, and then we click next. And you see I'm not using the entire interface. In another scenario I might then use, year, number of seats and other pieces of information. Right now, all I do is I provide only the mandatory field because I'm only doing happy day scenario. Okay? And again, I can now execute that step and see how well I'm progressing. And it executed. Did you see it? Okay. Now we are on the insurance page. And now you've seen how we use it. So it's just a matter of, is there an existing interface to the web page, to the web service, to the database table? Is there such a component? If yes, drag and drop it, use it. If no, then now let's create one. Let's assume we don't have a module for this interface, where we have to provide the insurance details. So what you would do, you would go to your intersection, let me do this here, and you start a wizard. This wizard can read or scan technologies that we support out of the box, but you can also extend the technology recognition capabilities. It's not a closed shrink wrap software, it's an open platform. This is, by the way, the only part where you do need programming. So don't get me wrong, this is not a code-free solution altogether. It is code-free as long as object recognition works. Okay, you don't code functions anymore and test automation frameworks. But if Tosca does not recognize the technology because you are automating, let's say, a small talk system, and we don't have an adapter for it, well, you know what? You can write your own. Okay, so you can extend its capabilities, but the code does not creep back up into your modules, and it does not creep back into your test cases. It stays well confined where it should be, and that's only in the technology adapter, where the machine-to-machine communication happens, and only for object recognition. Okay. Now you can see if I point the wizard at Tosca itself, the pop-up box tells me Tosca is developed in a .NET technology. Okay. So it's in C#. If I point this wizard now onto our browser, on the browser content, it will say, hang on, that's a different technology, but it recognizes that automatically and says, we are talking HTML here. If I move the wizard up onto my browser itself, the browser itself is a native application to your Windows operating system, and it was developed in C++ or C# probably nowadays. So it will then say, oh, hang on, that's probably a Windows 32 technology. I will talk Windows 32. So if you point it on a green screen, it will do the same. If you scan a database, it will talk SQL. That's where the technology adapters come in. Okay, this is where the machine-to-machine communication happens. Now what we will do is I will scan this interface quickly. But what I will do is, instead of scanning the entire interface, I can also scan a region of the interface. If I'm not interested in the interface, then I can say, hang on, I only want those 4 mandatory fields. I want the occupation, which is mandatory, and I want the next part. Okay? And now it scans only those regions and tells me what's part of that region. Okay? That can speed up, that's particularly useful for those of you who have a bit of experience in HTML applications. HTML applications scanning everything, they can be extremely busy, particularly when you scan under the hood. If you have ever implemented a Google Web Toolkit application, you know what I'm talking about, because it keeps loading into the document object model again and again. Okay. All right, so what I do now is I choose what I want. Okay, so I say, I want the first name, I want the last name. This male and female sounds a bit odd. That actually is the date of birth. And by the way, I indicate also that these are mandatory fields for the user later on. So the name, and then we also use here the gender, sex. And that's all I want. And the occupation, also indicate that this is a mandatory field. And then the next part. And I can give the module a more meaningful name. And I call it insurance details. Create module. Now, that module so far is nothing but a precise interface of what we define. Okay? It's just a proxy to the interface. There's nothing else in it. There's no code in this side. Okay? There's nothing that suggests it's used in a particular scenario already, the fields that are. But we can now do exactly what we did before. We can now say, I want to use the enter insurance details now in my test scenario. So you drag and drop this. Didn't grab it. You drag and drop this element now onto your test case, and we get the insurance details. And now we can fill that with meaningful information. Date of birth, first 1970, and then sex. And you see here we already have information. There's male and female, or in the occupation. We have all these occupations. Where does that information come from? Where do you think? Exactly. When it scans that interface, what it also does, it not only scans the objects, it also scans the content of that object at that time. Don't get me wrong, that is not necessarily a complete list of options, because if you have dynamic behavior, depending on scenarios and actions that you do beforehand, that content might change. But in my particular scenario, if I'm doing a happy day, you know what, it is exactly what I can provide as a happy day scenario. So it speeds up my initial creation. We will replace this anyway. Okay, and then we say click next, and again, all we do is we execute this now and see how we go. That was the creation of an interface and the use thereof. Now, you've seen how we use existing ones and define a test scenario. You've now seen how we create it in the first place and then use it. Now what we do is we simulate now a green field. Let's assume this interface is not here yet. That's just a screenshot in a Word document, and all we have is the requirement specification. But we don't want, we're in an agile environment, we don't want to wait until these guys have developed the entire system. We want to already specify a test logic. Okay. So what we can do here is, we go to the test case, and rather than, fold this in, and rather than dragging and dropping a module, we say now, can you create a test step? And that's a manual test step, and we say, choose coverage. Okay, this is what we do here, the insurance coverage. And I will use a couple of fields. I'm lazy with typing, so I copy paste that string over here. And here's my first action where I do the preferred start date. My second action, the insurance sum. my third action, the payment option, and my fourth action that should illustrate what we need to do, the merit rating. Okay, and then what we also want is obviously the next one. Okay, and now we provide some meaningful information. Here you see the preferred start date can be anything in the future, it can't be in the past. So if I was to type in a hard-coded value here, and I was to type in, let's say, the 1st of the 3rd of 2014, that would work well today. But what would happen in March? Anyone? It will fail. It will not fail for technical reason, but the application will block me and say, a start date for an insurance can't be in the past. Why are you wasting money? That period is gone. It's in the future. So rather than providing, and this is another problem usually in test automation, is the test data management. We come to this a little later in more detail. But rather than providing here static dates, we can obviously provide some dynamic functions. So we can say, use the 1st of the month and just add 1 month for me. Okay? And you can construct here anything, plus years, plus weekdays. Well, then you can define public holidays, floating holidays for different regions. If you had any requirements around, Singapore Exchange is a customer of ours. For example, you cannot trade on public holidays. You can't trade on weekends. So you can't provide any dates that fits into the category. So you can calculate this, and we can translate this value prior to test execution also, and see what it is at runtime. So right now at runtime we get the 1st of March 2014. Okay. And then the insurance sum, what do we have? Maybe 10 million. Yeah. And then the payment option yearly, for example. Yearly, merit rating, and then we click next. Okay, and again, we have not created a module. There is no. The assumption is there is no code, but we can still execute the test step. What will happen is it will just fire off the manual execution engine. It will tell you, okay, rather than acting on the actual system, I need to provide step-by-step guidance for a manual tester. And now it's like, you probably have seen this before from other technologies, it's just a step-by-step instruction. So what it tells us, shall use these dates and do these actions, right? And you can go into a subtitle mode so you get your real estate back. And this is what I will do. I said the 1st of March, that's fine. I shall choose 10,000 or 10 million. That's the insurance sum. Payment option is yearly, that's fine. And then merit rating is 3, that's okay. And then I shall click next. And that succeeded, that's why I can say it, that's that case. Test step has also succeeded. I've just executed it in manual fashion right now. Okay, last but not least, we want to validate now the quote. And I'm going to show you a few other aspects of model-based testing that come into play here. 3 things. One, for once, we want to extract some information from the system. I dropped it. Can you hear me? Yeah? We want to extract some information from the system. So we use the quote number. The quote number in this example illustrates a case where you don't know what the value is prior to test execution because it's generated by a system, not by yourself, right? But we might need that number later on and hand it over to another system, hand it over in an email to a client who has asked for the quote and say, look, here's your reference number if you wanted to look that quote up. Secondly, we want to validate here that table. In particular, we are going to validate the specific value, and I'm going to show you a few things that typically happen in there and how you can avoid them. And then last but not least, I'm showing you timing. Obviously, any machine-to-machine communication needs to be timed, so you don't want the automation to jump ahead of the game because it won't find what it's looking for. You need to time it logically, ideally, with your system rather than statically. Most test automation engineers today throw in sleeps, waits, seconds, whatever. If it's a bit more sophisticated, then they use also dynamic conditions, meaning you look for something to hold on where you know what the system does and what its logic is. Now I'll show you that. Rather than building the module, you have seen how we do this. I'm just using for the sake of time, I'm just using an existing module. So I'll go here to my insurance calculator and I have here a quote already. And all I do is again, drag and drop that onto the test case. Okay? And in the quote number, what we want to do is here, we are not providing that information, but we want to buffer that information. We want to buffer that information for later use. Okay? And the price list is this table. We want to verify something in this table. And we want to verify here a certain value. Let's assume we want to verify here this sum value. That's the value that we want to verify. Okay? And we want to verify this, as you can see, as a premium gross sum. So this is column 1, 2, 3. Right? I hope so far everybody can follow. So we say here, for example, column number 3. And then this is row. Which row is it?
5.
1, 2, 3, 4. Or if the header is counted as a row rather than as a header, as a separator, it's 5. Okay, so we could try 5. So try 5. Okay. But before I execute this, let me show you something. I go back now. And in this scenario, I'm using a courtesy car rather than no courtesy car, and I'll go next. What would happen, assuming that the header is a row, and 5 was correct in first place, what would happen now? You're dead in the water. Because what happens now is, the legal defense insurance slipped in, and now this is what we are validating. We're not validating the sum anymore, are we? Now in that sense, model-based testing in Tosca works like the human eye. Okay? You can tell it, look for semantic information. You know what? Don't want you to look at column 3 because there might also be another column that's coming in, or they might change the order of the table. And secondly, we want to look here for the sum, nothing else. I don't care if this is in row 3, 4, 5, or 6. 2 things have happened. For once, it is stable with regard to layout of the table in terms of semantic layout, the number of columns, and content. But secondly, we have our semantics back. Because now I know what I'm testing. I am testing here, not the click value is wrong, I need to replace this. I'm testing here for premium gross sum. I'm not testing for a row 3 and column 3 and row 5, which I then would need to describe what that means anyway. Right? So you get your semantics back as well. Okay, what we provide here is obviously our legal defense insurance will fail. Oh, it can fail, doesn't matter. No courtesy car is this price. Okay, and then we use here that value. Okay, and the third aspect that I wanted to show you is we need to time it. See, when I say here send quote, the restart button is disabled. I can't click it right now. Okay. If I send the quote, the restart button will only be enabled upon successful submission. Now it's enabled. Now I can click it. So what we will do is also we will time the execution, okay, accordingly. So what we can say here as one implementation, we can say here is, firstly we send the quote, but secondly, we will wait for the progress bar to show 100% completion. And only then we will click the restart button. Now that's the most primitive implementation of a logic condition. It works because we are asking the state of a particular object, in our case the progress bar. Okay? Now what if the progress bar wasn't there? What if there is nothing to wait on? You know, what if there's the spinners that you see, you know, and it's busy, and it's implemented inconsistently. They don't use the spinners everywhere. In some cases they use it, in other cases they don't. there's a better way to implement this. Rather than cluttering your test logic with a wait condition, which has nothing to do with test logic, it's a necessity for machine-to-machine communication, we can do it smarter. We can jump from here to the module attribute of the restart, and in the properties we can simply tell it, you know what, use a wait on condition that is true, and the specification is we want you not to act on this object until it is enabled. Now, two things have happened. Firstly, it's on the object itself rather than depending on another object. If that object is not there, you know what, then the system is flawed. But if the progress bar is not there, it might just be a design failure, right, or inconsistent implementation. Secondly, we could remove now very easily here this wait for progress bar because it's not necessary anymore. It will wait implicitly for that attribute to be enabled. Okay? All right. Now we have implemented our first basic scenario. And what I will do is I take this, which does all the verification as well, and I take this now and I will assign that to an execution list so we get a proper log as well, smoke test. Okay? And here we have the Mini Cooper. Remember, right now we still have a semi-automated test case because there's one step in there that we haven't automated. We've only built manually. Let's execute this. Now it prompts me as the user, remember this is the manual step. It prompts me as the user what I need to do. I get my real estate back, so first that's fine. I say yes, then 10 million is my instruction for the insurance sum, yes. Payment option is yearly, that's okay. And the merit rating I shall choose bonus 3, and that's okay. And then I shall click next, and that's still good. And then I shall click next. And it picks up automatically again because the next step was automated. So we have had the first 4 steps automated, then we intersperse the manual step, and then we have automated again. Now we have our first semi-automated test case. All right. Now let's fully automate that now. We come to the next step. How would you go about it? Again, you know, greenfield for this particular interface. How would you go about now automating this particular step so that we get to full automation? Incremental test automation. So what I will do is for this purpose, I will navigate quickly to that screen. So I can take any subset of steps and execute them in isolation. I don't need to execute the entire test case all the time. I say just execute the first 3 steps because what that will do is it leads me to the entry point where I want to be. Perfect. And now what we do is we create, assuming now the developers have dropped, you know, the latest build onto the build server. It's been compiled. We have access to the code. We have access to the application. It's up and running. The interface has been implemented. Okay. Now what I can do is obviously I can do what we did before. I go to Tosca, go to the Ember section where I maintain my automation model, and here say Start Wizard. And here's our wizard again. And again, I can say only start scan a region or scan the entire. Let me scan the entire for a change. I said scan the entire interface for me. Okay. Depending on your mode of operandi, okay, you can tell the scan to only scan what is visible and what a user on a graphical user interface and what a user can interact with. Okay, you can also tell it take the next shell of the onion and go 1 level deeper. Scan everything that's visible, but you can also tell it scan everything, regardless if it's visible, invisible, or if it's part of the document object model, or if it's even hidden in a JavaScript that will only be executed later and will add these elements to my document object model. So for those of you who have no experience, document object model is what the browser in this instance uses to render the actual application so that we see it, the users see it. Okay, this is how the browser talks to the content. Okay, this is what it is. Now I have here my interface. In my case, look, we only need the preferred start date, the insurance sum, the payment option, the merit rating, and then we click next. And I call this actually the coverage, and I create the module. Now back in Tosca, you will see we have now a coverage module. Here's the representation of it and what we have chosen for it. And now what we do is, let me make this very explicit here. See, this is currently the manual test step for choose coverage. And you see it's got a hand symbol on the actual test step, and it's got a hand symbol on each and every individual test action. Now what we do is, we go here to the module section, we take the coverage, and I drag and drop now the model, not on general in the test case, because it would add another step. I will drop it on an existing test step and see what happens. It's automated the whole lot. Let me do this again. I will make now a change so that you see what happens if this was not perfect. Let me make this, for example, blah. Okay? If I drag and drop this now onto the test case, okay, it will automate what it can find by name match. Now, the preferred start date, I could have made it more meaningful, just say start date rather than preferred start date. As you can see, it could not find that because it was not a perfect match. Doesn't matter, no drama. We marry them up logically. If you can't do it, we drag and drop this section over here, and now it's automated. Okay? Now we have a fully automated test case end to end. You can, by the way, at any point in time, obviously change that back. And now let me execute this test case again. It's the same test case. We haven't changed anything. Sending the code, waiting appropriately for the restart, validating, executed. Okay, so we've run the test case now in two fashions. We've run it once semi-automatically, and we have now enhanced the automation, and it's fully automated. I made a big claim that there's no difference in a model-based test automation world. Okay, there's no difference between the test case description for manual execution and automated execution. We only have one source of truth for test cases, not two versions. There's not one in prose somewhere that we then convert to code either through record and replay or by substituting its instructions with the arrangement of function calls, which has the same intent of testing, but is physically two different assets. Meaning, in a script-based approach, if you change one or the other, the two go out of sync. You've got to make a conscious effort to keep them in sync. Okay? Not so in a model-based testing, because we separate the test logic from the beginning. Okay? It's a forced separation. Now, therefore, I can go here and I can simply say run as a manual test case, the same test case that we've specified. And what you will see here is, if we were to do this really now, we go here to our specification. You see here, these are all the instructions that we have to go through. Let me do this quickly. So we shall choose automobile and then click next. This is exactly what we do. And then we shall enter some information. So here's the make. It copies automatically the value into the clipboard, so you don't need to type everything. It speeds it up a little bit. I think there's some ideas of data injection as well. Now then we have here engine's performance is 100, that's good. And then the list price we shall fill. And what else is here? The mileage per year. And then we click next. And that's good as well. Then here my first name and my last name. And you see it's already a bit tedious. Date of birth. Mail, that's okay. Employee, that's okay. And click next, that's still good. And then we go start date, that's okay. We shall choose 10 million, that's all right. Then yearly, and then bonus 3, and some of you might already get a Vidice. It is boring. So we click next, and that's fine too. Now we shall buffer this information, okay? That means what we have here, we can probably copy paste it out here. So what we do here is we buffer that information, so we did that. And then we shall validate that the gross premium sum, and see your semantics are back. You know exactly what you need to validate, not count rows and columns. So we need to validate the gross premium sum. If this is this value, 1,200, and that's good. And then we shall send the quote. Whilst we are sending it, probably says, no, hang on, wait until it's finished. So that's good as well. We waited, and now we shall click restart. And we restarted, and the entire manual execution is succeeded. Now, why I'm doing this, firstly, I wanted to show you the entire execution. There is no difference between a manual test case or an automated test case. It's always the same source, the process in plain English. Okay? But secondly, the same test case has now been executed 3 times, and you see the difference. The semi-automated was about 50 seconds, the full automated was 14 seconds, and the manual, although I had assistance with typing, because I could just copy-paste these values into it, it still took me 130 seconds. So there's significant, if you can automate, there's significant cost savings, obviously, in running it automatically, and secondly, it's less tedious. It doesn't, your attrition or turnover and stuff will be hopefully less. All right, so that was the first basic scenario. Now what we want to do is, we want to use now not just data that we specify in the basic flow, but we want to build in variations. Now we won't have enough time because to go through the entire test design, but here is a test design that was built using computer-aided scenario design. We have certain objects such as vehicle data and personal data and others, and we classify that, and then we can generate these instances out of them, test instances. And we will now inject these test instances into our basic flow that we have defined. So here we have this Mini Cooper. Let me now simply do a few steps. Firstly, we convert now this to a template. Okay. Once we have converted this to a template, we can assign a data source. Before I do so, I will say, look, don't use these values in here that we have specified, but marry those values up from our template. Okay, and now I simply drag and drop here that test sheet onto my Mini Cooper template. And what will happen again is the same name matching technique. It will try to marry it up. So in this case, you will see it's not a straight one for one flat row. It's actually object oriented again. But it did find a mileage per year, which happened to be in an object which is vehicle usage. It's not the vehicle itself. It's a separate entity, it's a separate object that tells me how am I using this vehicle, right? And it found obviously the brand and performance in the vehicle data. It found the name in the personal data. So it will try to go through your data model and automatically marry up your process flow with this data. And there's one more step to go here. We have the quote. We also want to validate against data that we define in our model. And what I can do is here, rather than dragging and dropping, I can also go straight here and say extract external link, and it comes with auto completion. It will tell me what my data model consists of. And I can go now here and say, look, what I really want here is the premium and .NET gross value. Okay, that's what we are validating against. And then what I will do is I simply say generate test instances to illustrate that to you, that you see what the outcome is. Okay, what it has generated here is a folder that now contains all these variances that we had defined in our test data. It uses the same process flow. We can build in conditions, obviously, into the template, which will then be triggered depending on what data you feed into it. So it might go left or right depending on what your data set is. Right? But here you see we have a BMW, and the first one is, as an example, an Audi. All right? And then I can take obviously the entire folder to my execution list and assign this, for example, not to the smoke test, but to the user acceptance testing, and say, can you please run the entire suite? And the BMW. And off it goes now for 6 scenarios. Now let it run quickly. What we will do in the next step is, we have now, as you've seen, we have built the basic scenarios where we have done a brownfield application of it. Now we scan interfaces and sample test cases straight away as automated. We have done a greenfield approach where we don't have access to the source or to the application. We can build manual test steps first and test logic and automate later. So there's no forced direction. You choose. Do you want to come top down or bottom up? Okay. And then we also built in variances into our business process flows. In this case, it's just getting quotes, but we can get many different quotes for different purposes. Some might include, courtesy cars, others don't. Some have compulsory insurance only, others might have full coverage. So we're testing whatever the test logic determines for us to trigger each and every possible behavior of the system, where you can then obviously also factor in negative testing and boundary testing and other types of testing. What we will do is in the next step, and then we have seen there's no difference between automated execution, semi-automated execution, or manual execution. Any change that we make to the template, to the specification of the test case, is immediate in both worlds. If you do an audit trail on a test case, you can do it in plain English with the business analyst who doesn't trust the automation in the first place, or you can run the automation if you're happy with them. Now we have executed all these test cases and we are back here in the execution. They probably failed. Let me look for the reason. Because the quote, see, when you look at the quote, I didn't update the values, so we have different values, but it's a correct failure. We expected $1,624, but it only said it's $1,505. So it failed for a good reason. And obviously you can also look at these details. It takes a snapshot during runtime. It's settings that you can do. And it tells you, look, this is what I saw at runtime, actually. So it's correct. It was right. Now, what we want to do is now, we want to enhance our, I said there's no difference either between technologies. It's not just working for HTML and Java and .NET and any other GUI. It also works in exactly the same principle for non-UI. Okay, so let's use a non-UI example. I have here a live example from the internet, and you can try this out yourself. Okay, here's if you look on the internet, there's publicly listed services that you can use. There's credit card validation services, there's stock quote services, there's weather services that you can use. I'm using here this as an example. You could use any other, doesn't matter. And this is a credit card validation example. So here's my WSDL file definition. Sorry for those who are not technical. That is web service definition language. This is where the web service contract is defined, where it says, I'm a web service, I can do credit card validations, that's the operation that I offer, and what I expect is a credit card number is an example. So it's the definition of the web service. What I will do is, I say copy just that URL where that is defined. I don't need to actually download the definition. And then go to my module section and say here, I'm using an XCAN. By the way, this is all live on the internet now. We're using the Wi-Fi connection here from this building. And now you could have a file as well if you have locally defined, but you can provide a URL. And here's what I type in. I said, this is the URL that I want to scan. Okay. And we are scanning now, we are crawling actually on the internet. We are scanning that WSDL file. It will also crawl through the WSDL file and say, are there any embedded schemas? Right? So it will go through the schema and read the schema definitions in. And by the way, everything you get back is still object-oriented. Okay? We don't flatten out these services. We keep them as they are. So if you had, for example, a service for an insurance contract, and on a contract you have the primary insurance holder and you have got beneficiaries, and they have addresses, we keep that structure. We don't flatten that out, and you have not later on a hard time to find which address actually belongs to which guy. Is that the beneficiary or was it the main insurance holder? I will only use one binding, that's fine for me. And I say save. Okay. And go back here, and you see here I have now a module which is an interface to a web service. How do we use it? We drag and drop that module onto our test case. In this case, the template. Let me open this template briefly. And see, we have here now validate credit card. And let me expand this briefly. And here I have a valid card. Let me type in 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8-digit number. That's probably an invalid number. And let me expand here on the response briefly. And here's the response definition. And that's the response here, the valid card response. For those of you who want to try it, easy learning, this credit card returns either true or false, depending if the credit card is true or false. So we validate here, against true. We want, sorry, not here. We validate on the response, on the result, that it says true. Okay? That's in the response. Now let me execute this briefly. Run in a sketchbook. It executed live. And if I expand that now, you will see credit card verification failed because we expected true, but this is a wrong number. Now I have my master's card here. And for the sake of speeding this up a little bit.
Wait a second, I need to write that down.
So I jump to where that is defined, and I use now a valid MasterCard number. And let me execute this in the sketchbook again. Or did I put it in the wrong field? You're right. Yes, so sorry. That actually was wrong. It should have been in there in first place, but let me use a valid one here. So credit card. And now we execute it again. And it succeeded. All right? So that's a use of a non-UI. If you had a table, same thing. You scan the wizard. With the wizard, you scan the database schema. It will list you all the tables that are in there, and you can say, I want the table contacts. I want the table, insurance contracts. I want the table customer. I want the table whatever. You scan it. It gives you an object. It gives you a proxy to the table back, and you can use it. You can say, look, I want to insert something. I want to validate something. I want to delete something. Whatever action you take. What you see in here so far, let me quickly show you something. I reinstantiate so that each and every scenario is also updated with this credit card validation now. So you will see it here, credit card validation. Now let me show you something. I can bring in here, as I said, it's a completely customizable platform. I can bring in here an image as well. I can make this a little bit smaller. So it's huge. which is also a bit smaller. Oh, thank you. That's very lovely. And I will expand here everything so that you see that. Now, not only can we execute all of that in a manual and in an automated fashion, but what we also can do here is, that's it, yeah. So, and now let me show you that. I can print here, and I can print this test case now in any kind of formats. I'm only doing a preview on the screen. And here is your test case description. Okay? So we see a full test case description that you can send out as an audit, that you can execute manually, that you can print and take it along to a meeting. It's plain English. It tells you on each and every step. We select the type of vehicle on that interface, and what we do is we select car and click. When we get to enter vehicle data, we only do make, performance, year, number of seats, list price. That's what we enter. Here is the information. I can give this to a student on the street who has no clue about your system, and he can execute because it's precise. Action by action, it's precise what they need to do. Okay? No difference between a manual and an automated field. All right? Now, that's so far building something and building it for different types, brownfield or greenfield, UI or non-UI, technology A, technology B, semi-automated, fully automated, manual. We come now to the next step. Okay, that's building. What happens, however, if there is change? What's the impact of change? You want to know how you deal with this, isn't it? Now let me make, therefore, a little change to the actual code. Let's start with a code change. We have here, as you can see, in the application, on the second interface, okay? On the second interface, we have a make. And when the make was defined by the developers, it also got an ID make. And what the wizard will do when it scans the interfaces for building modules, it will, depending on the technology, suggest what the best options are. If your objects in HTML, for example, have IDs, IDs are very stable. If they don't have IDs, it goes to the name. If there's no name, it will try to use an inner HTML text as an example. So it will try to progressively use whatever is the most stable identification. You can, however, choose anything and any combination of. Now in our case, since this is well developed and there was an ID provided, all it did, it said, okay, default is ID. I haven't changed that, so it uses the make ID to identify. Now let's trick now the system. Let's say someone in the code, we are doing a code change here, okay? Here's this make that is automatically generated in a JavaScript in HTML. And we rename now the make to brand. Brand, okay? So someone changed the code. We save the code, okay? And now let's execute the test case. And let's see what happens. We have here I still have the reporting open. So we have here the test case Audi as an example. Okay. Now let me execute only the first two steps because that takes us straight to where it happens. We don't need to watch it until the end, okay? Oh no, actually let me do end to end because you see something interesting as well. I execute now the Audi and observe what happens. It executed the first choice, right? And now it sits. It sits and waits. What it does, it tries to find the make. Periodically, you can define how long, shall it wait for a minute or only 30 seconds? And it will periodically test for the make, because it could be just slow, isn't it? Now, after it times out, it tells me here, make, I should input Audi, but it says here, I cannot identify an object called make. Okay? Now before I go and fix it, I'll show you something. You don't necessarily need to go and fix it straight. You don't lose your automation and your run just because that happens. If that was a test case that we're already running for 10 minutes, you don't need to go back. What I can do is I can simply say here, hang on, well then copy paste the Audi in there, and I will mark this one as failed with it couldn't find it, but you know what, from there continue. I can intervene at runtime and say, okay, I take manual actions right now, continue the actual test automation, and I'll fix it later. Or you can abort, obviously, if you wanted to fix it straight away. Okay. Okay. Unable to identify object. So what we do is here, from here, I can now jump to the test step. This is where the test step was defined. Since it's all object-oriented, it's all referenced. I can jump from here straight to the module, and that's the module where it happened. See, here's this make. You don't need to, as a test analyst, you don't need to look in the details, but I show it to those of you who are interested. Here's the vehicle data, here's the make, and the make was identified by technical ID make. But you don't need to do that. What you can do instead, you go to the vehicle data, as I said, jump to this vehicle data. We go back here, and what I can say here is, can you synchronize my module with the new version of that system, of that interface? So it goes back, and a wizard will now scan the interface again, and it will tell me what the difference is between, firstly, if there was any update to data within the object, different from those that I had grabbed earlier. It tells me, do you want to keep those that you have defined, or do you want to take a new snapshot? I say, no, I'm cool with my data, so don't interrupt me, but give me what's different. And here you see a new control tab that you haven't seen before. It says there is an unidentified control in the module, which we know already, the make, which I can't find on this version of the screen anymore. But what I can do is, I can either drop it, or I can rename it, or I can find something else that matches to it. I find here make, and that's the make that I'm looking at, isn't it? So I can say, you know what, take this make, and take this make, and merge those two. Okay? And now it merged my module with the new version of that system. And all I need to do is save the module and go back. And now if we go to the start here again, and we go to our test case, which is here this Audi that we executed, we can now say execute again. And it's working. Okay? So what you do is, all you do is, you go to the interface where it failed. Could be a UI interface, as in this case, but could also be a non-UI. Could be a database table that they changed, or it could be a web services, or it could be an XML file, or it could be a Swift protocol. Okay? And you synchronize, you're done. That's when it's a technology change. Let's say there's a business change too, and we need to get some additional information. Remember earlier, when we built the module for the coverage, that's not in here, that's here, this coverage. It currently only has these 4 kind of attributes. But let's assume there's additional information now that we have to include, which is mandated. Right? The way we go about this is here. Let me select only the steps to navigate to my coverage. So step 1, 2, 3, and execute those 3 steps. Wrong order. That's okay. It will fail. It will say it can't find what's on the next screen because I selected them in the wrong order. See, I can't find the first name which is on the next screen. That's all good. So I close the execution, go back here, and I can simply actually drag and drop in the sketchbook the order, because all it is, it says there's a certain sequence of steps that I want to execute, and I can execute here the sketchbook again. Okay, now we are here in this product choice. Let's assume that we need to include here the courtesy car option as a mandatory field for our business process testing, because it has an impact on the quote if there is courtesy car chosen or not. The way we do this, again, you go here to your module section, and here we have the coverage, and we say now, can you synchronize the coverage with the version of the latest interface of that particular part of the system. Okay, and here it is, and it tells me these are the 4 that I had chosen earlier. I want to include the courtesy car now, and all I say is save module. One control added, the others unmodified, and I go back to Tosca. So here we are, the courtesy car is in the module. Now, assuming that you have here your choose coverage, every test case that uses that module has automatically been updated. Okay, it's there. Now what I mean with there is it's there as an option. It has not changed yet your scenario, because it shouldn't. It might have been deliberate that you don't use that particular mandatory field in that version of a test case in order to trigger a negative test case scenario. Okay? But if we now wanted to include that and marry it up again with test data, I could now go here and say this is probably under the vehicle usage. No, sorry, under insurance product. And we have here now a courtesy car option, see? And all I do is I drag and drop this to my test case. Okay? And if I now re-instantiate here all these test cases, you will now see here's a courtesy car option. Here's a courtesy car option. Is there anyone without? They all have some. Now, this one has no courtesy car. See? It's all populated, and it's populated with the right intent. And now obviously you can execute this again. Let me execute the Audi again. And we go through this. And you will see it will now firstly find the make again, because we fixed it, but it was fairly quick. But it will also click and choose no courtesy option for this. Now what we've done is went through the entire sequence, and we're at the end of my demonstration. We have started by building a basic scenario on a brownfield application where we use existing modules. If it's not covered yet with automation, we build the module and we use it then. We have used it on a greenfield application where we don't have access to the system, and we build the manual test logic first and integrate it, incrementally enhance our test logic. For the time being, we just execute it in a semi-automated fashion, and then we automate later. We have seen how we can then marry up these processes, the basic flows, with all the variations. Ideally, we use something like, a systematic approach to test design, that we get the optimum set for the biggest risk coverage, but without running any redundancies. And then we have looked at manual execution, semi-automated execution, fully automated execution, and last but not least, we said, look, now it's all up and running, and that was pretty fast building it. But that's only half the story. What if it's a non-UI? We need to integrate with our application. We expand it then, from a single technology into multiple technologies, and that on it goes. You can do, obviously, you could factor in now an a green screen interface or a Swift protocol if you needed to disperse in the messaging. And all in one scenario. We don't need another concept for business process testing because it's all implicit. Through that neat separation of concerns, it all comes out of the box already as a technology. And then we have it all up and running. Then what's the question? Yeah, that's good. But what happens when we go into maintenance? They change the code, they change the business logic, they change the test data. So we then factored all of that in and we said, look, what happens if they change the code? What happens if they change the business logic? What happens if we need to factor in some variances? And that's for me the basic demonstration, walking through a concept or the implementation of model-based test automation. I can show you one more trick. One last trick. Call center applications have that as a requirement often. They, for example, need to test the tab order, okay? Because call center guys, they have a look at the screen. They look outside. They daydream, whatever. They talk to a person with a headset, but they know exactly if they hit the tab key 3 times, then they know exactly they're in the first name. If they hit it another 2 times, they are in another field, that they know. They don't do mouse clicks, way too slow, driving it by mouse. And they don't look at this. They listen, they talk, they do. Now, if you needed to test that as well, and let's say you had a function call in test automation frameworks where you enter insurance details, the function call would include how you get to the entry point. The function call would include what entry fields you have and what clicks you have to do and what parameters you need to fill. And the function call would also have any assertions that you are making, right? So it has an assertion in there. But since it's coded in the function call, it would always execute in the same order. It would always start with first name and then a surname and exactly as you have programmed it. And that's where one of the fundamental differences is. Because sometimes we get this question, hang on, could I do with business process testing components not something similar? No, you can't. Because the function call in itself has some embedded sequence that's coded in.